In this session, we will have a glance about introductory glance about evolutionary computation and very specifically genetic algorithms. So in order to know what is evolutionary computation, why it is used, it is mandate to know about the basic concept and the background behind the evolutionary computation. Evolutionary computation, usually it is used for solving optimization problems. Usually single objective optimization problems are more common, but nowadays as engineering is becoming more and more complex, it is mandate that we have to shift ourselves to multi-objective optimization problems. So evolutionary computation is a traditional method which very keenly solves both the single objective and also the multi-objective concepts of optimization problems. So basically evolutionary computation is a population based algorithm, which means it could be incorporated when there is only when there is the number of solutions is more or infinitely finite. So when there is a lot of solutions, we could take the solutions into the evolutionary process, and we could filter out in every step by step, and finally we could evolve into a better solution. So it works on the principle that in an evolutionary process, the best solution or the best species survive, and the species which is not more competent enough will be rejected from the system. So it goes under several iterations, and iterations we call it as number of years in general terms. So as the number of iterations increases, the solution gets more converged to the best solution. But evolutionary computation always never converges to the exact best solution. Rather, it gets closer and closer to the best solution. So genetic algorithm is one of the popular form of evolutionary computation. In the 1950s, the concept was laid, and several researches were carried out. But it was in the mid of 1980s there was a dramatic increase in the utilization of evolutionary computation in solving optimization problem. So evolutionary computation usually is used to solve real-time based problems. So this simple flow chart represents the steps which is involved in evolutionary computation. The process initiates with an initial population creation. Initial population creation. So the number of population should be, the initial population has to be very larger in size. So it will have a best solution, average solution, and also the worst solution. So this initial population has to be taken into consideration for evolving the best solution. So once the initial population is created, it is passed on to the next section called the selection. So in the selection process, we will have some weightage functions. Also the objective function. So the objective function varies for several problems. So in certain problems it might be single objective, which means there is only one objective that has to be optimized. But in most of the cases there is several objectives, that is f of x, g of x, h of x, and so on. And these variable objectives has to be optimized, and this objective function will be reflected in the selection process, and the most relevant solutions will be taken into account. And once the selection process is done, this selection process, the next process called the reproduction, it takes place. That is, the initial population will mate among themselves and create offspring solutions. So offsprings is nothing but is the chromosomal change. So there will be an interlinkage of chromosomes, and this chromosomal mating will happen, and we call it as crossover. So the function generally it is called as crossover. This crossover process happens, and once the crossover process happens, we take it to the mutation process. That is, the process will be getting, the species will be getting adapted to the environment based upon the small minor changes in the mutation. So these are the four important process of an evolutionary computation. After which we have a process called the stopping criteria. The stopping criteria is a point where we intend to stop the algorithm. So once the process is complete, if it is necessary that if we think that the process is over and it is time to cut down the evolutionary process, we'll mention this as stopping criteria in the this place. Usually the stopping criteria will be 100 generations or 1000 generations. Generations are nothing but the iterations will be taken into account. So here this is an performance of a genetic algorithm with a population of 12 candidate solutions. So in the first image, we could see that the solutions are distributed along the space. So it could be assumed as a three-dimensional problem. I mean the three objective problem. So the solutions are scattered over the space, and once after several iterations, the solutions are converged near a global optimal solution. So this is what we call it as optimization. So once after the convergence takes place, it is our duty to take down the best solution. So role of GAs in a global problem. A GA largely motivated for a global search and optimization problem, as I already mentioned. Global problem is very, very difficult to solve because it deals with several objectives and several constraints. So a genetic algorithm from its inception, it has a very good success rate in solving global optimization problems. And recent days, several customized version of genetic algorithm incorporated with several other bio-inspired algorithms are also taken into account. So there is a misrepresentation claims that it can handle most complex problem, including problems unsolved by any other method. But it is like a myth. Even genetic algorithm fails at times, and it is like the success rate is maximum and is not complete. And the importance of fitness function and the coding of theta. The fitness function is to be always informed in the beginning of the process. So the problems may be of a maximization problem or a minimization problem depending upon the intensity of the problem. So usually the problem will be of a minimization or a maximization problem. So these two problems will be considered. Say for example, finding the optimal cost between the cost and the comfort of while purchasing a vehicle. It is a minimization problem. So you have to get a car with a minimal cost and maximum efficiency. So your cost has to be minimized. So it is a minimization problem. So when you consider the same problem to be when concentrated with comfort, the objective function is to take a solution which is maximal in comfort, then it is a maximization problem. So usually there are two types of problems. So based upon which we define the fitness function. So the next topics, that is the process of the various process in the genetic algorithm and the various operations in the genetic algorithm will be discussed in the next class. Thank you.